we're in 2.7 and we're going to do example 2. Find the equation of the tangent line to f of x equals the square root of 2x plus 1 at a equals 3. So I'm going to go through this example in the style of 2.7. If you're looking at this at a different time in the class, realize we're probably going to have an easier way to do this. So with that being said, how do we find the equation of the tangent line in this section? Well, we're given a couple things. We're doing this specifically at a particular x equals a value at 3, and we have the function. So graphically, what's going on here is, we have some curve, who knows what this looks like. It's like this, and at 3 for your x, we're trying to find the equation of this tangent line. And so, first of all, notice that it's a straight line. And so we have a couple forms of the straight line, y equals mx plus b. This is called our slope-intercept form. And this is the simplified form that we want to always put our equation of the tangent line in. So that's one version. You can get away with just that version, but often students know this other version, y minus y1 equals m times the quantity x minus x1, which is called point slope form. So don't have to know that one, but often students use it as a tool in this problem. So that's our goal. And notice that a common ingredient in these formulas is m. And m is the slope. And so we know now how to find the exact slope of the tangent line. It is the derivative at x equals a. And so we need to use, in this section, the definition of the derivative at x equals a. So let's just go ahead and do that. That's something that we're going to need to plug into this equation of the tangent line at the end. Alright, so a little motivation here that we need to do this limit definition. I'm going to use the one with h. It's okay to use the one with x goes to a, and it doesn't matter which one you use. Know both, be comfortable with both, but I'm not going to tell you to do a problem using one over the other. It's going to be your choice. So here we go. I'm going to use the h definition. So this is my f of a plus h, so I'm just going to plug in the 3 right away. And so I have f of 3 plus h minus f of 3 all over h. So carry your limit notation throughout. Now I'm going to use the function square root of 2x plus 1, and I'm going to substitute in 3 plus h for x. So I need some parentheses around it to show that 2 is times the whole thing. And then plus 1. Get really good at plugging in the function, the a plus h part. The f of 3 could be done as side work, or just go ahead and plug in 3 for x in the function, and then you can figure it out within this larger definition of a derivative limit thing. Okay, so now just go ahead and simplify this. There's some things to do in there. So for example, we could go ahead and distribute the 2, and we get 6, and then that's a plus 1 if we combine like terms. So overall what we're going to have simplified inside that first root is going to be 2h plus 7. And then you can find the answer to 6 plus 1 is 7. Square root of 7, you want to leave that exact, so just leave it as square root of 7, don't approximate, all over h. So that's simplified. Now we know if we plug in, based on example 1, or at least I told you, you're going to get 0 over 0 every time. Okay, so you're going to have to do some algebra here. It's a different scenario than when we had a rational. Our problem child is still the h, what we learned for limits like this is a little trick to extract that common factor of h, because it's not at all obvious how to do that. So what you do is you multiply by the conjugate of, in this case, the numerator, to extract that factor of h. So it's just a little trick that we learned in 2.3. So same applies here. I'm going to multiply by the conjugate, which is 2h plus 7 under the root, and then change it to plus instead of minus, which is present, and then my square root of 7. And then I gotta put that in the denominator as well. Next step is to actually multiply out the top and then leave the bottom factored, because remember, we want a factor of h to cancel, and so we want it in factored form in the denominator with that h that's a factor. Alrighty. So expanding the top, I get 2h plus 7 times its, with square root squared, so that's going to simplify, and then we're going to have plus square root of 7 times the square root of 2h plus 7 minus the square root of 7 times the square root of 2h plus 7, and then finally we have minus square root of 7 squared. That's going to simplify a lot. What we're going to get is a common like terms in the center that sum to 0, and then our first term is going to simplify just to 2h plus 7, and our last term simplifies just to minus 7. And so now you should see that when you simplify in this next step on top, you're going to get this in a form where you can see the factor of h. Just 2h on top. So the h's will cancel, and then you can plug in, drop the limit notation, and you're done. So I'm just going to do that in the step here. You drop the limit notation, plug it in, h equals 0. Oops, just kidding, I already canceled that. Okay, so just a 2, and then the denominator we have 2 times 0 plus 7 under the root plus square root of 7, and then simplify here, and we're going to get square root of 7 plus square root of 7, which is 2 times the square root of 7, which simplifies even more, and we get 1 over square root of 7. I'm going to be fancy and simplify that by multiplying by the square root of 7 or square root of 7, so we don't have a root in the denominator, and finally we get square root of 7 over 7. So that was a lot of work, and what we just figured out was the slope of the tangent line. We will have shortcuts later on, by the way, and it'll be on the test material for exam 2. You will be required on this third quiz and for your exam 1 to do this type of calculation, even if you know the shortcuts. We will learn shortcuts. It's not always going to be this much work, but you're going to gain an appreciation of what the derivative means, and by doing these problems in this way. Alrighty, now what were we doing? We were trying to find the slope as one of the things of part of a larger problem. We want this equation of the tangent line, not just the slope. So I'm going to do this in 2 ways, and there's even more than these 2 ways, but these are the most common. So first one is to use y equals mx plus b twice. What we have here is, remember our equation for y is, or f of x is 2x plus 1 root of that. We're doing this at a equals 3, and we just figured out that m is equal to the square root of 7 over 7. Now, if we use y equals mx plus b twice, what you want to do first of all is figure out what b is, the y-intercept. So you do that by plugging in the y, the m, and the x. So the y is something that we can plug in here. We actually already found it. And so I'll just do it as side work again. We did it within the definition of a derivative as that second term on top, but we did get square root of 7 here. So plugging in, we're going to have to y equals mx plus b, we're going to have square root of 7 equals square root of 7 over 7, and then we're going to have our x as 3 plus b. Now we can solve for b. So I'm going to subtract this term from both sides, and we have the square root of 7 minus 3 times the square root of 7 over 7, which is a little bit of a pain to do by hand, but we can do it. Getting common denominator, multiply by 7 over 7, and 7 minus 3, we get 4, so it's 4 square root of 7 over 7. And so, finally, we use our y equals mx plus b the second time to plug in just the m and the b. Then we get our equation aligned. So it's square root of 7 over 7 x plus 4 times the square root of 7 over 7. That's the end. I'm just going to do quickly another way, and it doesn't matter to me which way you do this, but do put in the simplified y equals mx plus b form at the end. Another way is to use a point slope form. And just do the algebra to put it in the slope-intercept form at the end. So we already did the legwork for this, where we found our y-coordinate at a equals 3, or x equals 3. So doing that, we just put in our square root of 7, our square root of 7 over 7, times quantity x minus 3. And then we do a bit of algebra here by adding square root of 7 to both sides, distributing square root of 7 over 7 in here. So the square root of 7 over 7x minus 3 square root of 7 over 7, adding square root of 7 to both sides, and you can see that we're getting the same thing here as we should. So combine these like terms with a common denominator like we did in that other example, and you'll see that, well, I don't know, we'll just do it here. Kind of cheating with my other method there. So here's the square root of 7, or 7 times the square root of 7 over 7. So now we finally get square root of 7 over 7x plus 4 square root of 7 over 7.